And we're up. Hey everyone, my name's Ed Clarke from Yojee. We're about a 3-year-old company from Singapore, and we're asked to come and talk about artificial intelligence and how we think about that and actually how you can use it in industry. And I think the best place for us to start is actually in this title here. So we see artificial intelligence as a tool, and then we say if we're going to improve businesses, if we're going to make things easier, better, cheaper, faster, where's the place to start? And we have this saying in the office that we really want to look at painkillers and not vitamins, because we're going into an industry that's very old. We're going into an industry that is struggling to change but trying to change, and we're going into an industry that's met a lot of you people here that are doing e-commerce and marketplaces and omni-channel strategies that are really struggling to adapt to the innovation coming from the sell side. And that's my experience. So I started throughout Southeast Asia working in e-commerce, doing big data optimization of databases, customer acquisition. And we kept seeing founders complaining about fulfillment. We're great, we can get our customers, we can sell our products, but no one's loving the delivery of the product. And how do we solve that problem? And that's really the way that we look at artificial intelligence as one of the tools that we use to solve that problem. So Yojee as a company is 3 years new, seems about 20 years worth of work that's gone into it. We're listed in Australia, so we're a public company. We've taken slightly different a route to the traditional Asian startup, and certainly I saw the ASX is here. You're welcome to talk to them or myself if you're looking at different options of funding. We've got offices in 5 countries across Southeast Asia, Australia. Our big mission is to connect the logistics industry, and one statistic that blew my mind when I was working in my old company was that in Indonesia, 70% of online purchases are outside of the capital city, Jakarta. And then you look at the technology that's coming to solve that problem, and you see that everyone was focusing on last mile. And last mile is a small part of a supply chain. It is an important part. But what was happening is everyone's goods were disappearing across country or across border when they were moving, and that was the big problem in the industry. So today we've been working with some of the world's biggest companies. We've been working with UPS, DB Schenker, Yojee, which is France's biggest logistics company, Sinotrans out of China, some great little Malaysian companies, startups as well as legacy companies in helping them solve their problems. And that's where we really start. So some of the problems that we look at with artificial intelligence is that there's these huge variation volumes day to day, because if it's raining, you guys don't go out, you buy online. The next day, there's piles and piles of goods in warehouses. Singles Day, Black Friday, Christmas, all of these different events where networks just fill up, warehouses fill up, trucks fill up with parcels, but then there's no other way to move things, and people are looking to scale elastically. Cross-border, so now we're seeing companies starting to sell into different countries and buy from different countries. Now we're shopping online in China, we're shopping online in the US, and we're looking at these ways to manage this. How to get efficient, but to minimize your fixed costs. Everyone's looking to minimize their fixed asset costs. And then all of us that are buying online, we want to know where it is and when it's going to arrive. And that means that you want a delivery window. You don't want an SMS that says between 8 a.m. and 10 p.m. today your parcel will arrive, please be at home, or we'll try again another day. It's very, very painful. So again, we looked at the technology landscape. So we saw a very fragmented technology. Every sector of the supply chain had a different software provider, and every software provider focused on one company. How do I optimize my company? But a supply chain is just that. It's a chain of different organizations that are working together to move goods. So how do we give everyone visibility so they can plan, execute, and invoice off a single platform? And there's a lot of human interaction and decision making. If you can imagine that every one of us in this room ordered a parcel today at all of our houses across Malaysia, someone has to work out the most optimal way to deliver that. A human mind, we're finding even the smartest dispatchers we can beat by at least 30% on kilometres using by giving an AI the solution to do it. And there's very limited use of data to being able to understand what your networks cost and understand how to deliver your goods in a way that's sustainable, efficient, cost-effective, and visible to your consumer. Something really interesting that's happening right now is the China Belt and Road Initiative. And again, you're seeing cross-border movements. What's happened is people have stopped using ships and now they're using trucks and planes out of China to move goods across Asia. Causes a lot of problems. Every different country you must change truck and trailer so that you can drive through the different country. There's a lot of coordination, there's a lot of visibility issues. So this is an example of an $8 trillion investment by 2027 on investment to help us online consumers get things cheaper, better, faster from the logistics industry, but it comes with its own challenges. And then we look at how we're doing things now, and right now we may have 1 or 2 warehouses and we deliver to door. And this is essentially what human-delivered supply chains would enable us to do. But we know there's a lot better way, and what I want to show you now is an example of an entire supply chain operating. So we've seen this slide before, and this is an example of the power of AI now, but I'll move to this video here. So this is an example of a China-wide national supply chain. So we've used data and we've run the big fat lines are what we call line haul, so containers and pallets moving across a country. The small dots are the last mile deliveries. So you can see that there's so much movement that's happening outside of the supply chain to get things to where you need to go. What you'll see now is this is the last mile. This is Beijing delivering. There's 5 warehouses having to deliver things across the city to 30, 40, 50 million people in a day. And this is an algorithm deciding the routes of the drivers. So traditionally, instead of one driver, one postcode, you can see things crisscrossing, maximising the utilisation of vehicles and minimising the kilometres travelled to do so. As you move into these pictures, what you're understanding is that by letting an AI use Google Maps or Here Maps or one of the mapping providers, and an algorithm look at one person's decision to get something at 1 p.m. to 2 p.m, another person's decision to get something 10 a.m. to 11 a.m, you're creating more and more rules in your network, which makes it more and more difficult for human decision makers to assign. So we're doing many trillions of calculations to come up with a solution like this. What we're doing is using all of the different rules that are human-created rules. Sometimes we take some away to create efficiency, like removing the rule that a driver belongs to a postcode. Remove that rule, and we can already save a number of vehicles. We create new efficiencies by providing delivery windows and running models of, should I put a warehouse somewhere else in this type of interaction so that I can save kilometres between me and my customers? So at Yojee, we use algorithms both for real-time assignment of vehicles and management of parcels, but also for planning. If I'm going to bring on a new customer, I can run a model like this with historical data, and I can say, it will cost me this many vehicles additional to my network. I'll need to look, if I need a new warehouse, where should it be? I'll get all of the new data and run a model like this, and I'll look at it. This model is 1,025,000 kilometres. If I put my warehouse over here, I can do 800,000 kilometres. It's going to be a much cheaper operating model to put my new warehouse over here. And so the painkillers for these businesses is planning their assets, organising their drivers in a world that drivers are changing all the time. And the best drivers are quite efficient. Everyone else is learning how to do things and is not necessarily so efficient with how they work. So then we look at, in a simplistic version of how we do e-commerce deliveries. We start with things like bigger vehicles as opposed to, or motorbikes instead of bigger vehicles. So we can actually the cost per hour of assets and deliver different models. But then with AI, you can start to look at rules that were traditionally human rules that most people don't think about. And that's things like a virtual hub. And so for an algorithm, a warehouse is just a piece of information. It's nothing more significant than that. So if we say every day we're going to take 3 full trucks and park them across Kuala Lumpur, how much can we save in vehicles by using motorbikes that are doing 2 Ks per leg instead of trucks that are doing 5 Ks per leg? So we can decentralise from the warehouse, and we can run models, and we can move close to the customers, or we can deliver from store, which we're actually doing in Malaysia now. So we can start to offer 2-hour from store. We can start to offer motorbike deliveries with fixed delivery windows. And we can model all of this out even before we execute to see if it will work and what cost it will have. This is an example here of a company coming to us with a heap of data. They're trying to look at how they optimize their network. And so they get something like a spreadsheet. They'll upload their spreadsheet into the system and throw it at the AI and say, show me how to solve this problem and how many vehicles I'll need to do these deliveries across Perth. There's some fixed jobs in there, so some people like to have their drivers coming to their address every day, and there's unfixed work that we're trying to optimise every driver. So we can select the drivers that we want to optimize with. All we have to do from here, which would traditionally in this company be a 3 or 4 person dispatcher job, in about 12 seconds we click the names of the drivers, we click optimize, and we get a route, and you'll see that coming shortly. So the jobs are coming here, clicks assign, you can see everything working here. You've got different rules. Should I start my drivers at warehouses? Should they start at home and just keep delivering if it's an on-demand service? And we can do this for, here we go, optimize, click my rules. Service times, how long does it take to do a delivery? Click optimize, 12 seconds, you have a result for your network that sets up your whole day for execution. There, we've got the completed button, and there's the plan. Different colors, different drivers, you can check the rules, and then suddenly your day can be planned the day before in about 5 minutes. You can go and focus on business development, customer service, and all the rest. Different areas where we're using technology and artificial intelligence in our platform. So we do offer a crowdsourcing solution for these peak periods. Analytics is a great service for big companies with lots of data that are trying to work out what they're doing. In logistics now, as I mentioned, with the Asia Road Network and the Asia Silk Road, you're seeing cross-border platforms being created so people can move e-commerce goods by truck, by air, enabling smaller retailers to sell things across border and do things with visibility to them and their customers so they can create a great customer experience. And essentially that's where omni-channel is coming from now, that the brand like a Nike is looking at running their own supply chain so they can control the customer experience. And this visualization here is an example of one of the great challenges that technology is facing in logistics and the e-commerce boom. So we work with one carrier. Their Monday is 4 times the volume of their Tuesday because everyone's been purchasing Friday, Saturday, Sunday. And on Monday, they have to work out how to deliver things. And so you can see here that we've got an own fleet model, and what we also enable through our platform is like a Facebook add a friend. The friend is a carrier. You can add a friend into your network. Instead of getting the IT team on a 3-month integration project, everyone has a phone number in our network. You can add them in, they can accept, and you can pass jobs to them through our system. You maintain the full visibility. That small company that would otherwise not afford AI to optimize and meet the SLAs that you're passing down to them in terms of delivery times can do all of the modeling out of the software, and then they can get the proof of delivery information digitally, which sometimes means a 30, 60, 90-day faster payment for the upstream carrier. So we're seeing through Singles Day to Easter this year, we did this type of model where all the jobs left over in warehouses would get thrown into our digital network at about 10 a.m, 11 a.m. And the crowdsource guys would come in, pick everything up, optimize, and go out and deliver with full visibility. So elastic scaling of logistics networks, which traditionally, like the iPhone launch, a product would come out, every vehicle in, say, the UPS brown truck fleet would be used, and then they're finding anyone they can to deliver. But everything gets lost in that network, and people are calling up, where's my phone? Where is my phone? And no one knows, but that cost of customer service is huge. So being able to provide the optimization to plan the person's day to deliver the goods to the expectations, along with the visibility through the technology, through the platform to see where everything is, enables a network of less customer service, faster payment, and full optimization. So you actually get more dollars per kilometre travelled as a logistics company. Again, looking at this model here, Singapore into Malaysia, we're seeing use cases now of e-commerce companies or brands in Singapore loading up containers and pallets with goods that are going to multiple different destinations. And we're actually storing all of that manifest information in our system, and we can actually consolidate and deconsolidate up and down road networks so they can actually reduce, instead of having a half vehicle go to Penang and a half vehicle go to Kuala Lumpur, because that's how technology let them work before. We can do consolidation and deconsolidation in real time through the network and plan those runs and give full visibility so you know, where are my yellow board shorts that I bought online? It's all in the network. We're not just tracking big items and then suddenly one day you find out that your item's arriving. So we can actually let people plan all their resources in their warehouses, the number of drivers they'll need, when they're arriving, so what time these people should start work, and then how to deliver them out in a way that the customer can see and experience. So this is a bit of a high-level way of we plan our logistics networks. We really focus on things like route optimization, which traditionally has been thought about the fastest way between point A and B. But really, with artificial intelligence, what you're looking at is the optimization of scheduling. So how can I get as many jobs done in a day with the cheapest asset and be closest to that customer when I'm beginning that process? Machine learning guided mapping. So actually, how do you use your network? How do you get the right type of carrier? How do you set up your warehouse? Capacity optimization. How do I plan for what I'm going to put through my network and model my new customers so I understand my business and the cost before it arrives? Asset planning. How do I plan each person's day? The first driver, a driver on his first day should be just efficient as the driver on his 100th day. And that's the ability of the system to tell you what to do next. And then we look at things like autonomous task allocation. So being able to step away from the dispatcher model and letting the system manage the network. And finally, out of this, I think what we're starting to see is a whole number of new logistics models. Thanks everyone for your time. Hope you've had a great day, and I'll be around, so come and have a chat.